Well, good evening, everybody. Welcome to our last meeting of the year. And thank you for all who've been here tonight. We have pizza and soft drinks. And welcome to everybody who's joined us remotely. We're glad to have you with us to spend your Tuesday night at the Garden State Java User Group. So without further ado, I'll start sharing my screen. And as usual, we will do our introductory slides. All right, our standard agenda, as you all know, is we thank our sponsors every month for their generosity and their support for all of our endeavors that we do here at the Garden State Java Group. We have a few what's new items, and then one of them is a nice little surprise. I'll introduce Justin, and then when we come back after his talk, we'll talk about some upcoming events and also what some of our friends are doing out there this month as well. And then, as usual, we'll have a giveaway to a license to IntelliJ IDEA. So our platinum sponsor is JFrog, and we thank them for their support over the past 2 years now. Our silver sponsor is Azul. So they have their own downstream distribution of the OpenJDK. DevNexus is our partner, and the DevNexus conference is April 4th through 6th next year. The call for papers has been closed. And we have our per meeting sponsors, JetBrains and Jakarta EE, or the Eclipse. JetBrains provide the licenses for us to give away. And then Eclipse Foundation, we have their crowdcast hosting that we provide to all the Java groups. We initially used them when we first formed over 2 years ago. So what's new? We, as you may know, we are a member to the microprofile working group. So that means we get to participate in the meetings, we get to vote on various things like specifications that are going to be released. But with that, you can join as a guest member of another working group. So we've decided to do that for the Jakarta EE working group. And this just made sense because myself, I'm a committer on 2 of the projects. We've adopted those very same projects, which is Jakarta Data and Jakarta NoSQL. So this was a no-brainer to do that. And it didn't cost us anything extra. Microprofile 6 is on the verge of the GA release. There's been some issues on that, but we think it's going to pass with this ballot. The 2 specifications that I just mentioned are on track to be on Jakarta EE 11, but that won't happen until about a year from now. There is a guide to contributing to Jakarta EE 11 that Reza Rahman put together, and he's been distributing. If you want to know more, please see me. I can provide you with the Google Docs. Last week, Java 20 went in ramp down phase 1, which means that the feature set in the form of JEPs or JDK enhancement proposals are now frozen. And there are 6 of those. And I should have mentioned them here, but basically there are second previews or second incubating features of the ones from JDK 19. And then usually at the same time, the expert group is formed for JDK 21, which will be released in September of next year. So you can see the list of folks that are on that expert group. One of them presented here with us, Simon Ritter, about a year ago. So, and then this is the same folks that were on JDK 20. The only change was there was somebody different in the Eclipse Foundation. And we do have a new Garden State Java Group member, Ambika Makhila, and she was born on November 12th, just a month old now. And yes. To those of you who know, Neha is one of our is on the leadership team here at the Garden State Java User Group. And so this is their first child. So she's recovering nicely. And, you know, this is their, and I did say your life will change, as I always say, since our kids are grown. So, but anyway, this was just awesome news. So with that, we're happy to have Justin Lee here with us. And I will read you his bio. So Justin is a Java champion and Kotlin fanatic. He has been programming in Java since 1996 and has worked on virtually every level of application stack, from database drivers all the way to application servers and front-end interfaces. A longtime advocate of Java and Kotlin, he has spoken at conferences and user groups all across the United States and Europe. He is an active open source community member, contributing when and where he can. He is currently a principal software engineer at Red Hat, working on Quarkus.io. And he can be found on Twitter and GitHub, and his handle is at Evan Cooley, with CHOOLY. So without further ado, Justin, please, the floor is yours, and thank you for being here with us tonight.
Fix bugs, whatever might have you. Often it generates terrible code. I was in a previous gig from years back. I was looking at some front-end technology, and I won't name it because it's gotten better, I think, since then, and doesn't deserve the hate that I gave it at the time. But I wanted to build like a simple form. It was like a text box and a button, HTML. And when I looked at the generated code, it was like 8, 9, 10 divs deep before you got to the actual visual components. I'm like, this is terrible. Anyways, so, but why do I love it with all these problems? So one of my second real big gig out of college, it was early 2000s. I was living in Denver at the time, and it was great. We had just conquered Y2K, which it was a big deal. So it was heady days. I was working for a financial systems company. We weren't a bank, but we worked with banks in lending agencies and whatnot. And we had this business model for this app that we're building, and it contained all the state and federal regulations all across the country, right? So things for collateral and whatnot, they were all modeled together by the lawyers. And Rational Rose, if anyone remembers Rational Rose, this will be a trip down memory lane for all the gray beards. Or gray hairs, I should say, because not everyone here grows beards. Anyways, it was in Rational Rose, and the lawyers updated that. And there were hundreds and hundreds of entities. It was huge. When we printed it out, it covered the entire wall, and you had to like take a step back so you can kind of see it. You know, it's like when you get too close to a picture, you can't really make out what it is. It was enormous. It was just massive. And we had to model that in code somehow. But that model would change frequently because laws change frequently. And sometimes the lawyers learn like, oh, we didn't understand that now, but we think we do now. So they would change the model. So the easiest solution to keep up with all that is to generate the Java from the UML, if you remember UML. So we actually had a contractor who's no longer with the company, which made it even worse, who wrote a VB script to export this Rational Rose model into XML. Well, XML. It was technically valid XML, but you wouldn't want to use it today. So for context, it was pre-Java EE 1.0 days, give or take. I forget the actual timeline, but it was really early EE days. And we were working with like JSP 092 spec. So that wasn't even the final spec. And we built the entire application server ourselves because at the time they were going for like $10,000 per CPU, which got really expensive really quickly. So we had a tool called Bob, the Business Object Builder, to generate this code. And it would parse this XML and it would generate the Java code, okay? Now the downside to this particular system is there were hundreds of code snippets in different files. And every code snippet, every file might just be like a single line of code. And you couldn't tell what in the world was going on because you only had that one line. But Bob would take all these templates, smash them together and generate Java code. So I rewrote it because it was very hard to maintain and it was very fragile. Now, I rewrote it in XSLT. And it was in 2003, so don't judge me too harshly. We all thought it was a great idea. And it was better than Bob. And I called it, because I love puns, I called it Joe, the Java object emitter. I'm a big fan of puns. For those of you who know me, have probably already figured that one out. So I picked Joe. Now, it was his own version of hell. Does anyone remember XSLT? Yeah. Right, I told you it was a trip down memory lane. XSLT is actually a Turing complete programming language, functional programming language. It was, and it's all written in XML. It was not fun, but it was better than what came before. Like you could actually see like chunks. They had like C data blocks for like large chunks of code, so you could see code in context at least and figure out what was going on. And it was very effective. It did its job really, really well. We had a bug in, like I said, we built our own application server. So we had a persistence bug where relationships were being broken, where what we did is whenever you saved, if A referenced B and then B referenced A, so you had like this circular reference between these like many-to-many relationships. If you saved A, it was supposed to save B, but then you're saving B, so it tried to save A. So we had to build in code to catch those cycles. And we ran into that bug rather soon, actually. So we fixed it with one commit, except it was in CVS. Anyone else remember CVS? Yeah. CVS was terrible. It versioned every individual file. So each file had its own revision, and you start off with version 1.1.1.1. And then when you committed a revision, you got 1.1.1.2 on that file. But only the files that changed got new revision numbers. And if you branched it, you got 1.2.1.1. It was terrible. So overall, we had 1,500 Java classes that were managed by this and generated. Does anyone remember Java EE10? Where you had home classes and managers and locals, and we generated all of that out of this XML model. And, right? Well, buckle in. It was something. So, but I've loved CodeGen ever since because we did like amazing things at a really remarkable scale at that point. So, what are some benefits of code generation? Multiple language support. So, depending on what you're doing, you can emit different languages. For if you're a polyglot shop and you have Ruby and Python and Java and C#, you can generate code in whatever language you want, right? Depending on what you're doing. Adding a new language becomes trivial. You just add a new template, right? No big deal. You can get consistency across languages. So one of the things, I worked at MongoDB for a while, and all the drivers kind of evolved separately, and they all had like their own nomenclature and terminology. And so when you moved from one driver to another, or one language to another, you had to like relearn some terms, which made it very difficult for larger shops to operate. So you can create consistency across those languages because they all come from the same source, all come from the same templates. So you can have consistent method definitions, so they're all named the same thing, give or take. You can run into problems with like keywords in languages switch sometimes. So method and parameter naming can be standardized to the extent that's possible across languages, because you see them all in the templates and you can figure out like, oh, we call it this over here, but that in whatever, just switching back and forth. You can also get the ordering right and consistent. In my own project, it's not even code generated, but I wrote all the code by hand. I had similar methods, and as I got to looking and debugging stuff, I realized I'd swapped some parameters, but you don't really know it because you're working with this code in isolation and that code in isolation, and you get some inconsistencies, and it's weirder. But if you're doing code generation, again, you see them all kind of together. You can standardize it. You can actually generate documentation with it. You write your documentation once in your template file, your source model, whatever it is, and then generate that documentation for each, say, client library, whatever you're doing. And as I said in the last one, you can do mass bug fixing. If something breaks, you update your templates, your code generation, you regenerate everything, and boom, all of a sudden you fixed a whole bunch of stuff, right? But obviously there's some dangers to it as well, right? Because not everything, there's no such thing as free lunch. So one of the dangers of code generation is mass bug generation. If you mess up your templates, you messed up everybody downstream. And we've all been there. Fragility is a legitimate risk. Depending on what template you're using and how it fits into your build system, it can get awkward. And the process can become complicated if you're not really intentional about what you're doing. Depending on what your build cycles are and distribution across teams and locations and languages and such. And you might also end up with the low beer truck factor. Who knows that term? All right, you're at work with your coworkers, you're going out to lunch. Bill wasn't paying attention, steps out, boom, he's hit by a beer truck. He's dead or in the hospital. But Bill was the only one who knew how to do the code generation stuff. So now everyone's screwed. So you have to make sure, as with any other system really, you have to make sure that more than one person, more than a handful knows what's going on. But oftentimes don't deal with the code generation. So it's just the nerds like myself off in the corner who are doing all the fun stuff and no one else wants to bother it. So you have to be careful with that. Now for the polyglots, I personally like working in multi-language scenarios. You should be careful when onboarding a new language because the time that you're building up these new templates and the generation process can be tumultuous and can introduce oddities in your system. So, and it's just complicated bringing in a new language. Even if you're like, we're going to start generating Kotlin instead of Java because Kotlin is close. You still have to onboard all your developers to the new language if it's new to the team. And as I mentioned, the different capabilities can get in the way. One of the issues that we ran into at Mongo when we were trying to unify all the stuff is we could do a lot of cool stuff in the Java driver because Java is a very cool language and the JVM is very capable. But our PHP team, for example, couldn't do some of the stuff because PHP has no threads, which is difficult, but workable. But it also has no state. Like it's very hard to maintain state between requests. Had to do some fancy stuff to maintain things like that we just took for granted on the JVM team because it's just what we do. So some examples of code generation, because you're probably using code generation and you might not realize it. One of the most popular ones these days is gRPC coming out of Google. Your model, an interface definition language even, and you generate code out of it. And it's amazing, but it is just Corba without all the runtime stuff. WSDL, if anyone's still doing web services, still, SOAP, which are sort of the exact same thing, but not really. You have OpenAPI, it used to be called Swagger. Anyone using that? It's fun stuff, yeah. I like the documentation that it builds, and I like the test harness stuff. That's pretty fun. Also MapStruct, which I've dabbled with a little bit recently, trying to fix some stuff in Quarkus. Not as popular, but it's out there. Lombok. I mention it because there's a lot of people who rather enjoy it. I don't think you should use it. It really, really messes with stuff. Yeah, I'll just leave it at that. So Jackson, anyone use the Jackson JSON library? How many of you know about Afterburner? So what Afterburner is, it's a module that will generate the codecs for you. So all marshalling and unmarshalling in and out of your JSON objects and maps, it'll actually generate that code for you as part of your build, or I think it does it at runtime, I forget. Anyways, but it'll generate bytecode so that it doesn't have to do all the reflection stuff every single time it's parsing your stuff. I've not used it, but it's supposed to make things faster. It's like Afterburner on a jet. But I loved it so much, I actually added it to my own project for my MongoDB Java Object Document Mapper project. If you use Java and Mongo, check it out. So that's its website, and it is terrible. I know that, but I'm not. and more recently, Quarkus.io, which is the project I work on. One of the things that Quarkus does that it's not immediately obvious, but it is one of the ways that we can do amazing things that we do, is we actually generate a bunch of bytecode as part of the build cycle, which you may think that's what builds do, right? Is they generate bytecode. But we will actually look at your bytecode, see what you're doing, and we will generate the bytecode for all like your persistence units, your REST endpoints, your Kafka routes, all that sort of stuff. We'll actually generate that bytecode at build time so that whenever your application starts, you're actually starting our generated code, which will bring up your application and it's ready to run state. So there's not a whole lot of class path scanning and reflection going on. And we use a couple of libraries to get that done, and we're going to look at them. So this is my favorite part. Now, I try to make things, can everyone read that? The room is okay in the back with the font size? All right. What if I meant to do this before control. Let me at least change the theme. So it's at least, that's at least easier to read, right? Yeah. That's the one thing I really forget is the screen color. So typically when I do give presentations, I normally just use code. I don't usually do a lot of slides because I like having people ask questions, or more specifically, I like people having the option of asking questions. You don't have to, but sometimes you're in a, I don't understand that. Can you go back and explain? That's how I tend to structure these things. So as I'm going, you have questions, just fire away and we'll get to them because we have a lot of time tonight. Is there are 5 different options for generating code that we're going to look at. There are 2 ways, there might be more, but there's 2 ways that I can think of to generate code in a project. You can either generate source directly, which I kind of prefer in a lot of ways, or you can generate bytecode directly, which is what Quarkus does. So we're going to look at options for both, and we're going to see. So we have down here, I don't want to bring too much for the camera. We want to come down here. So I have a very simple test. What is, all right, close all of that. So I have a very simple test. Those other tabs. I'll come back to you. So I have a very simple test here. If I can get rid of that guy on the bottom, thank you. So all this test is going to do is we're going to create a new hello world object because that's what you do the first thing, you write hello world. And then we're going to run some tests. So we're going to call a method, and then we are going to make sure that it returns what we expect to do it. And then just for grins, we're going to call a different method on the bottom. So nowhere in this project will you find a hello world.java because we are going to generate it 5-ish different ways. So the first thing we want to look at for generating code, and we're going to look at them so kind of see contrast between the two. And we're going to put you, oh, I normally use an external keyboard, so sometimes this laptop keyboard gets in the way. So one is called Roaster, and the other one is called Java Poet. So Roaster is actually a JBoss Forge project. It gets a lot of use inside of Red Hat and JBoss projects, or at least it has traditionally. The other one is called Java Poet, and it comes from Square, the mobile payment people. The thing I like about Java Poet, I think Roaster is simpler to use in some ways. The thing I like about Java Poet is there's also a Kotlin Poet. So if you're also looking to generate Kotlin code, the APIs are very similar. Ironically, one of the ways they differ is that they swap some parameter orders, which I noticed a few weeks back, which made me a little sad. But we're going to look at both of them simultaneously because they're both similar enough that it gets repetitive if we don't otherwise. So let's all right. the screen is smaller, so I don't know if. So the first thing we're going to do, I'm going to use my fancy new clicker if I can find the laser pointer. So we're going to create, it's called a Java class source in Roaster, and we're going to set the name and we're going to set the package, right? And this is all done using the builder pattern. We're going to add, just because we can, not that this actually is what it's supposed to be used for, we're going to add an annotation to this class, and then we're going to suppress warnings, because if you write a lot of Java code, you suppress warnings because of you're not doing generics right, or you're not, yeah, stuff happens and you don't really care about it. You want to suppress it. So we're going to suppress all of it because we don't care. We're going to add an import, again, because we can, and we're going to add this import for this class because we can. So before we go, oh yeah, and then one more before we get to our methods. Here we're just adding some JavaDoc. Just to show that we can, because we're generating source, and sometimes you want to read the sources, sometimes JavaDoc is important. It gets a little more complicated if you're doing a if you're adding a body to it, but in this case, we're gonna add the @sense because all good JavaDoc has an @sense for which API version it came in. And this one has been there since forever because that's what we're doing. So the same stuff in Java Poet looks a little different. Again, it's a builder approach. We're going to create the hello world. We're going to set it to public. And these are the two annotations that we're adding. And it's scrolled off. But as you can see, we're going to suppress all of it again. And then we're going to do those builders. So Java Poet has these things called code blocks, which are, as one you might guess, blocks of code. You can just pass in arbitrary strings of stuff and it will just pass it along. And we're going to add the JavaDoc and our sense tag. This is a little bit easier to read in some ways, but the code block stuff gets weird. All right, so we're going to stay here for now, and we're going to look at adding a method. It can get more complicated than this, but so we're going to create a method. It's called greet, the one that we saw in our test. We're going to make it public. We're going to declare a return type, and then we're going to add the body. And all we're going to do is we're going to do a print line, and we're going to call greeting, which we'll define in it. And we're going to add another annotation with a name, with the value of, for all my nerds, Inigo Montoya. So that's this method. And then we're going to add it. All right. Again, this is, you can do a code block here as well. This is a kind of an overridden method where you can add just like a simple one-liner. In Roaster, it would look like this. Again, we're going to set it public. We're going to set name greet. Now, one thing, if you use Roaster, that you're going to want to try is you're going to look at add method and you say add method takes a string. That's the method name. No. I got bit by this today, actually, because I was trying to like clean it up a little bit. Add method that takes a string is actually the entire method body. So it takes whatever you give it and boom, here's your method, which is useful, but unexpected. So don't get sucked into that one. Return type to void. Has anyone seen void class? Has anyone worked with reflection at all? This is the class representation for the void type. Void is one of the 9 primitives in the JVM. Int, char, double, float, byte, short, long, Boolean. Did I get them all? Anyways, they all, even though they are primitives, because reflection needs to have class references, you can do a .class on any of the primitive types and you'll get like an actual class object for it. So in this case, we need a class reference or a class for the return type, but it's void. So void gets its own class reference. Now, the nice thing about Roaster is you can do set body and you can pass in a whole block of code. So if you have something like really complicated, you can just pass in the whole block. The nice thing about this is like sometimes you have like complex logic that would be really, really painful to actually build out in a code generating template model like this. but you can actually, depending on how complicated it is, you can actually use string templates to like replace the like little tidbits down inside of it, and then just pass the whole thing off. If you find yourself down inside a method body, manually adding like add an if block and then the 3 blah, blah, blah for 4 loops, and you might have gone too far. Like I think if you're getting that into that much detail in your code generator, you might have made a mistake. But maybe it's what you need. Who knows? And again, we're going to add the annotation with the name of Inigo Montoya. So the second one is much simpler. So we're just going to create a method called greeting, which has return type of string, and it just is going to return hello world. It's about as simple as they get. And then this is just outputting the file, which varies depending on which library you're using, but it's ultimately not that interesting. And this is that same block in Barry's putting on a pantomime show for us. Like, I don't know what's going on. This is the same method. Now this one, as you'll see, does take the string name, which is why I got confused with roaster. I thought, we'll just make this simpler and all the lines will look the same, but no. This one will take the string of the method name. You can add your modifiers, return string, and again, add code. Could have used a code block there to keep without the escapes, but I didn't. And then we're going to build it. Now, to see this run and to see what's going on, let's run the roaster version of it. How many of you have looked at bytecode before? No, good. Every once in a while, like, oh, someone will say, I work with bytecode every day. We're going to look at it. So this is the test module where that test just ran. As you can see, it was build success. And if you look down inside, I think it's going to be in the classes directory, you can see there's our hello world class. Even though, as you can see, there's no hello world here. So this is our generated code. And if you look, IntelliJ is nice enough that will actually decompile your code. And as you can see, this is the compiled version of what we just made. But there's this lovely plugin in IDEA, ASM bytecode viewer, which does exactly what it says on the tin. We're going to close that. Now, just for grins, we'll go over some of this. It's not that critical, but it is a little bit interesting to see what's going on. You can see this is that enabled annotation that we added. Question? The build tool, the generators themselves will work with whatever. I just happen to have it all wired up with Maven, but I just have a Maven plugin that calls the generator. I have it like in this particular project, I have a wrapper that will take a pluggable generator, whether it's Roaster or Java Poet or some of the others, and it just delegates. So all the plumbing is done with Maven, but there's nothing about Maven specific to any of these generators. So if you're in Gradle, it's fine. If you're in Ant, also fine. It's just a question of how you configure your build to get those working. I know people who actually still use Ant. So it's astounding to me, but it works for them. So this is our constructor. We don't have really constructors, so this is what like the default nowhere constructor looks like. But more importantly, down here, let's look at our greet method. You see it's a public, there's the name, the signature is empty because it takes no parameters, and this V says it returns a void. That's the bytecode operand for void. This is the annotation that we added to the method. As you can see, now we're calling, remember this method calls system.println. So we're going to get the static field of system.out. This is actually a little bit simpler than what it would really look like. Anyways, so we're going to get the static system.out, and this is the field of it. This is what a class name looks like in bytecode. It's always for a reference type, it's always L. I don't know why. L, and then the internal name, which is just the fully qualified name with slashes instead of dots. Someone once explained to me why that is the case, and there's some history there, but it's just what it is. And then semicolon. Anyone ever done assembly language? way back in the day. This is basically assembly language, but for the JVM. The instruction set is much simpler than, say, x86. But for me, it was fun to go back, and when I started dealing with this stuff like 3 or 4 years ago through Quarkus, it was kind of fun to look under the hood to see what's going on. So I might be weird. So most method calls are invoke virtual because they're not final. If it was a final method, it would be something else. I was going to say invoke static, but that's not it. There's another operand for that. But this is because it will try to execute this method on that type depending on what's on the stack. But if there was a subclass of hello world that had greeting, it would actually execute this greeting method on the subclass of hello world based on what you loaded in the stack. A load 0 is basically like load this, is what that is. Anyways, so we're going to call println, and this is the method signature string. There's some bits on the end that returns void, I think, and then some stuff. So anyways, this is what the generated bytecode looks like, even if you're doing source code. I find it like, it's helpful, even though there are things I still don't know. Like these L0, L1, line number, the local variable table, max stack, max local. Not entirely sure what they do. In my day-to-day, it doesn't entirely matter because the library that we use manages that for us. But if you are generating line-by-line bytecode with ASM, which we'll see later, some of this you'll want to know. Anyways, so that's
invoke virtual, right? That's one of the 5.
Yeah, there's invoke static, invoke virtual, invoke dynamic, invoke interface, right? And then there was one more for if you had it like a static, if you had a final method, it's not a virtual function anymore. So invoke virtual doesn't work. There's a different bytecode for that. But for whatever it's worth, this is what the bytecode looks like that we just generated. So I think it's fascinating. But like I said, I might be weird. Just to see Java Poet run, we'll run the exact same test. And boom, build success. And if we, again, look at the bytecode, it should be, it did change. So it's roughly the same. There'll be some nuance in how this is all laid out. But it looks, about the same. Remember when we were just returning hello world? This is loading a constant. In this case, it's a string constant. If you look at the Java P output, it gets insane. There are symbol tables and whatnot that you're not seeing here, which are fascinating, but might be irrelevant. So those are the source code versions of it. They're relatively straightforward. You can work in Java code and not really have to understand the bytecode. But if you're generating bytecode, obviously you need to understand what's going on. So we're going to start with the simpler one. So we use a thing in, we use 2 primary libraries in Quarkus. We use one called Gizmo, which I think we actually just made up for Quarkus because we needed stuff that none of the libraries gave us. So Gizmo and ASM are the 2 big ones that we use. ASM is as close to the bytecode as you can get, short of writing out the actual numeric values of each bytecode by hand. But we'll see it. Gizmo is much nicer. It's a little bit more human friendly. So we're going to create a class again, and we're going to give it the fully qualified name here. And this class output is basically how do you write these bytes out. We can look at this class if you want, but it's literally just how do I write this thing in memory out to a file. Not terribly interesting, but rather than just leave it hanging, that's what that is. So again, we're going to add annotations. You can pass in actual class references, or you can pass, I think it will also support it should support string names. Yeah, so you can pass in a string. There are times when you want to annotate source code or bytecode with types that you don't necessarily have on your class path for various reasons, if they're external resources or whatnot. So you can just pass in the string name instead. That would be the fully qualified class name. In our case, enabled is JFR. Why am I blanking on what that means? Flight recorder, Java flight recorder. Exactly. JDK flight recorder or Java? Okay. Oh, they changed it on that, whatever. It's the flight recorder annotation. It's part of the JDK, so it's just there. And again, we're going to suppress warnings, and we're going to do all of it because we can. So I broke these up into separate methods just because it can get a little overwhelming to see some of this stuff. And I'm trying to keep it separate. It's actually pretty straightforward. In this case, we're going to create a method. The scrolling is killing me. Oh, that helped. There. So we're going to get a method creator. We're going to call it greeting and the return type. This is much nicer than having to call like the separate methods for the return type and the name. Yes, sir. Yes. The question is, when you're creating a method, can you specify whether it's an instance versus a static method? And that answer is yes, you can do, I want to say, I don't think it's, it is. So in that case, if you wanted it to be static, you would just pass it as one of the modifiers. Right, yeah, you would pipe, yeah. The, where it gets weird is these values are ORed together, so you could do, if I could type modifier dot static, so because it's all like bits basically is, yeah, exactly. So this would create a public static method called greeting, if that's what you want. It gets where it gets really interesting is if you wanted to do a generic method. You've seen those like public bracket t foo whatever. I don't know what that would look like. I should try that out. This would get a lot gnarlier, I would expect. Oh, it doesn't even have. Is there a type? No. I thought I might be able to figure it out real quick. Anyways, so right. So now it's public. This is actually pretty straightforward, and we're going to load. Remember that LDC that I showed you in the bytecode? In this case, this is that bytecode operator, operand. You have to specifically say go load this, load return. That function returns a particular type, but it will run this and it'll load, put it onto the stack for you, and then we're going to do the return value off of whatever comes out of that LDC. So this is what will get you that LDC hello world and then return 0. Maybe it's just return, because return will turn whatever's on top of the stack. So that's pretty straightforward for this. And the thing to note about these, which is sort of nice, is they are auto-closable, so you can use the try with resources. So when you're done with it, the try just exits and it'll automatically close. And because you attach it to the class creator already, it's already set on the enclosing class. So it's a little housekeeping for you. To get slightly more complicated, yeah, this is why I split them out, because this one's gnarly. So again, we're going to do a creator. The return type is, I think, void again. Yeah, the void type. Here's our name annotation that we've seen already. We're going to set it public again, and we're going to add this annotation to here. I don't know why I didn't inline this. I should inline that. Now, in order to call another method, we're going to create a method descriptor. We're going to call of method, which is a statically imported thing on top. And we're going to, this one's more important to see if it will let us. There. So we're going to get a method reference on, this is the type, this is the target class that we're trying to call the method on, and we're going to call this method called greeting, and we expect it to return a string. So that's how you look up a method on another type. In this case, again, because we are dealing with bytecode, you have to understand the difference between invoke virtual and invoke static and invoke interface, which I'd forgotten about. So you have to understand a little bit more of what's going on. In this case, because it is a virtual method, we're going to call invoke virtual on, this is the method we're calling, and this is the this. There's an implicit this reference, parameter, if you will, to instance methods. And so this is how you get that. It's a little weird, but it's just one of the vagaries of the bytecode. So similarly, we wanted to get that the system.out class, right? So we are going to get a field. We're going to call it out, and we're going to get a field on the system class called out, and the type of out is a print stream, right? So I got lazy. I started using var because that was getting a little ridiculous. So now we're going to read the static field because out is static on system, and we're going to get that particular field back out of it. And now we're going to call, we want a method because we want the print line method on that out. So much like we did above, we're going to get that method reference called print line that returns a void. And in this case, it takes a class. So this is the return type, and this is a var args list of argument types. So this gives us out on the print stream class as defined on the static field out. And now that we have all that, we can invoke the virtual method. We're going to invoke the printline method on the field, on the out field, and we're going to pass in this as well. And then we're going to load null because this method doesn't return anything, but you have to give it a return value. So this is kind of the no op in that case, that we're just going to return void essentially. This took me a second to figure out because it's not obvious what that syntax should look like. But now you know, and you won't have to spend a couple hours pouring through example code trying to figure out what's going on.
Does this actually do a return semicolon or it ignores it?
It's, does this do a return semicolon or it doesn't return anything? In bytecode, everything returns. So at the end of every method, there is a return. There just may not be a value on the stack to return out of. And we can look at the bytecode, but I'm pretty sure it'll look essentially the same except for some of the finer details. But this is bytecode, so there's no return, there's no semicolon involved because there's no source code involved. But if we wanted to see that bytecode, we're going to run it. How many of you think this code is approachable? Gizmo. Yeah, okay. Because it only gets weirder. So if we wanted to look at, why didn't that go away? All right, so that was in greeting, right? You can see there's a return in the bytecode regardless. And this one actually has a value that it's returning off the stack. So the bytecode difference is return versus a return. So if you're not returning anything off the stack, you would use that. If you were doing bytecode directly, which we'll see in a minute. So that's Gizmo. I actually think it's, as far as these things go with bytecode generators, this is fairly approachable, relatively speaking. And you may say, Justin, you're insane for thinking that. Well, you're insane for, let me repeat the question. Barry said, Justin, you're insane. So this is what this would look like in ASM. Yeah, already you can see that things are slightly different. So there's a class writer, compute max s and compute frames. Max s, that's the local variable table stuff at the end, max stack and everything. Compute frames, I used to understand what that means, but it was not largely relevant. So I have evicted that from cache. So now we're getting to some nitty gritty. So ASM is built on the visitor model. If anyone is really into patterns and whatever, this is the visitor pattern. And it is not great for generating code. It's actually pretty decent for parsing bytecode, but for generating it just gets awkward. So this just tells us we're going to generate Java 17 compatible bytecode. Every bytecode, every class file has like a version number on it, like what level it is. This just tells it to use whatever that number is. It'll be like 50, something obvious. So we want it to be public, and I forget what this flag is for. Everything extends a class, whether it's object or not. So here we're going to give it a name, and you'll notice that this is the fully qualified name without the dot class, but it also uses forward slashes. So this uses the internal name syntax. So when you see this elsewhere in the code, if we were to reference it, it would be L blah, 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 semicolon. So it's the internal name and not the class name that you use there, which is also terribly obvious. The signature has to do with generics stuff, and you can pass it in the name of the parent class, because in Java, every object has a parent, whether you give it one or not. And if you don't give it one, it automatically gets one to object. And then there are no interfaces on this thing, so we don't pass any. All right, so we're going to add an annotation. So here's that enabled one again. You can see it's the full internal name. I don't think it supports class literals there, because ASM is not that friendly. No, it only takes a descriptor. And you can tell whether it's visible or not. This actually has to do, if you do a lot of reflection, sometimes you can discover annotations on a class file element, and sometimes you cannot. Because sometimes those annotations are for the JVM itself and not for user code. So this basically says, can reflection see this annotation or not? I don't know that it would make a whole lot of sense for us as normals to generate bytecode with invisible annotations, but it depends on how exotic your needs are. Anyways, so we're going to call this method visit annotation, which goes off and does a ton of weird stuff in the background. And then we're going to call visit end, because that's how you end every one of these. So not complicated, but weird if you haven't seen it. Now, because this is ASM and not Gizmo, we actually have to generate our own constructors manually, because again, ASM is not that nice to us. So we're going to create every constructor. Every constructor is called init in brackets. If you've ever gotten like a really weird, if you've ever gotten an exception in a class constructor, a null pointer, whatever, you've seen this somewhere in the stack trace, I'm sure. That's what that is. It's just the name of the constructor method. Because they are technically methods, constructors are. They just have no return type. Again, okay, so you also have to pass it in the method descriptor, which gets more complicated as you go. But in our case, the constructor is easy. It takes no parameters. It's the default no-arg constructor we're generating, and it returns void, because every method signature has to return void, even though constructors don't at the source level. We're going to call visit code, which is where like function body would be if you were to define one. We are not, because it's the no-arg constructor. There are no fields to initialize. But we still need all this weird stuff. Remember the labels we saw? Here's the A-load 0. We're going to invoke special. That's one. In this case, this is how you invoke the super constructor, because every constructor has to either call another constructor on the class or a constructor from the parent class, right? If you've ever written a constructor and you didn't type in super, empty parentheses and there was no default constructor. Everyone's running into that, right? You forgot to call super on your constructor. That's what that is. And again, ASM doesn't give us that for free because it's not a compiler. And then you're going to visit the instruction because why not? And this is a special token in ASM for return. So that basically says this is the representation of the return opcode. And you have to visit that instruction to emit that off into your, in this case, your method. And again, we're going to do the labels. This generates the local variable table. Between the two labels, you can see here. I tried to fix the resolution so it wouldn't like scroll past the edge of the screen, but it got really weird. Running out of battery. I'm gonna have to plug in. Here's label 0, here's label 1, and this basically is the bounds for the function. Is there a power strip nearby that I can plug into? Just normal. 3-prong. 2-prong.
No, I mean.
We'll do, here's one. I have a power cord, I just have to plug it in. I didn't plug it in because I thought I would do that.
That's right.
Exactly. All right. He's got some chewing gum and some paper clips. Let's do it. And again, here we're declaring the max stacks and the max local. And you're calling visit end because that's what you do when you're done with the visitor in ASM, is you call visit end. And all of that is for the no-org constructor. Let's look. Why would we ever use this? That is a fantastic question. You actually get a lot more focused control on what you're trying to do. With something like Gizmo, it is good for kind of like higher level stuff. And I'm trying to remember what we do use it for inside Quarkus. A lot of it's like JPA related, but it is a very coarse-grained tool for some very high level stuff. If you wanted like very specific things that you wanted to do inside your method bodies, you would need something like this. But it's not fun to use. Mostly because the visitor pattern is weird to do in this, but all right, so let's take a look at the method greet, right? This one, yeah. All right, again, signature. Did I turn it off? There we go. No parameters, returns void, no generics, also does not throw in exceptions, right? Here's the annotation again. Visit end. Now we're going to visit code. This is, again, it signals that we're going to start the method body. Label, because why not? Remember how we had to call load static in Gizmo? So we're going to get static on this type, and we're going to get this static member off of whatever type that was. And in the descriptor, it will show us that it is a print stream using the internal name. Now we're going to load 0, which is essentially this. We're going to invoke virtual on this type. And, oh, I hit the scroll bar instead of the. All right, so we're going to invoke virtual, the method greeting. This descriptor takes no parameters, but the return type is a string, right? And it's not an interface. The next step we are going to call print stream, because what this does is it invokes the method. So in the bytecode will happen, it'll go off and invoke this method, and the return type out of this method will be on the stack, okay? This invoke virtual says we're going to call on this type, this method called printline, which again, if I can keep from scrolling in a weird place. So printline, in this case, it takes a string and returns void and is not an interface. So this is the end label, and we're going to return because we're done. And then the rest of it is just more local variable tables. So this is not terribly gnarly if you understand what's happening in the bytecode. But I have a tip for you when we get to the end of this. We're going to visit the local variable stack. So greeting is more of the same. It's much simpler because it just returns a value, right? And in this case, this is that LDC that we saw earlier. You can actually just pass in the constant that you want it to load. This can be a string, it can be a number, any Java type you can pass into that as a constant. And then we're going to call a return because we're returning stuff out of it. And we're going to do this. Now, I would show you the bytecode that this generates, but I wanted to. So like I said, ASM is not fun to work with because it can be very arcane how to get from where you want to be. But I'm going to confess to something that I did not at Java 1 because I ran out of time. So this is the bytecode plugin that we've been using to look at the bytecode. What makes it really fun is there's this tab ASMified. If you click on it, you can see that it actually shows you the Java code that you would need to write to use ASM to generate the bytecode for that class. And in fact, is exactly what I did to get this ASM generator. I just literally cut and paste out of that because I'm lazy and tricksy. But all that to say is when you are trying to generate bytecode and you're not sure, like, how is this even supposed to work, right? Go write the Java code that does what you want it to do, even though like some of the parameters might be not there or whatever. But you can write out the logic and source code, compile it down, and then view the bytecode in this plugin, look at this particular tab, and you can say, oh, I have to do this first and then call that and wrap this around. Now, it is weird. It does everything in these little code blocks. I don't know why it does that. I know that in terms of like escape analysis and garbage collection and blah, 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 every local variable is now scoped to this block and you can detect it earlier that it's going away. That, I don't know. That's a premature optimization if I've ever seen one. I don't know why it does that, other than maybe it makes it easier to visually see where things stop and start. But this is a fantastic tool to get you where you need to go. And we'll run it and just see. So ASM is probably where you're going to end up if you're looking at bytecode generation. It is not pleasant. I don't know if I have this particular one working. There is another library that I'm actually quite fond of called ByteBuddy. I do run it. Okay, I couldn't remember if I got this test working ever. There's one called ByteBuddy that is super powerful, but it is also really bizarre. So I won't go through all of it because honestly, I don't really understand a lot of what's going on here. ByteBuddy is really great if you're like generating proxies at runtime. So if you do, for example, Hibernate, if you're doing like lazy entities or many-to-one or one-to-minis or whatever, a lot of those values that get, if you ever gotten like a stack trace, you'll see like the weird like proxy types in some of your Hibernate stuff is because they've been wrapped in proxies to do some of the lazy initialization or the dirty tracking. Like Hibernate can track, if you call save on something and you've never actually changed anything, it can like optimize that away because why do the database right if nothing changed, right? So they use stuff like this for dirty state tracking on your entities. And you can generate proxies rather easily using ByteBuddy. To generate code out of whole cloth using ByteBuddy, it is not entirely obvious. So this works. I wouldn't recommend it because these are as simple as I can make it, right? One just returns a string, one calls a method and calls println. I actually had to go to the ByteBuddy mailing list. It's like, how do I do this? And the answer was, oh, it's easy. You just use an advice. Thanks. I don't know what that means. But if you have like really complicated methods, this gets really ugly really quickly. So, you know, choose the right tool depending on what you want to do. I actually use ByteBuddy in Morphia to do proxies for lazy loading stuff. Super nice. You can wrap it up. It's not complicated, terribly complicated. Now, all that said, and one I don't have an example of this because it doesn't technically exist yet. ASM has been the workhorse for decades now, literally, actually. But it is not great. The visitor pattern is not really accessible. It's not very approachable. There is a JEP, actually, that might be, I don't think it'll be in 20. I think it's too soon for 20, but might be in 21. But will be a programmatic API for generating bytecode that does not use a visitor pattern. It'll be much more declarative. It'll look a lot like each line for your bytecode, load did's constant, call this method, push that to the stack, returns whatever. Yes?
Question on the wizard. Whenever I say wizard, it definitely feels weird to to generate the methods using wizard. But what it makes me think is maybe it's not to generate, maybe it's to modify. You visit each call, and then it's easy for you to wrap it around.
Right. Now that is the question is the visit method is awkward to manipulate and generate code. We actually, for the most part, we actually use ASM and Quarkus because whenever we are analyzing your Hibernate entities, for example, to generate code, we will actually use the visitor pattern to bounce around your methods and to figure out. I have worked primarily with Panache, which is like a querying layer where we will generate, you implement an interface and then you just leave it alone because all the methods are defaulted on the interface. And then we will use ASM as part of the build cycle. We will actually then replace all those default method calls with actual implementations to call off to the whatevers. And we actually use ASM to do that, and we wrap it around the methods that are already on the class or not, depending on what the method is. So yeah, in those sorts of cases, it actually is quite nice. But if you're starting from scratch and you're having to roll through the visitor pattern, it gets to feel very clunky very quickly. This new API should change that. And the nice part is when a new version of Java comes out, ASM sometimes lags by a few weeks because they have to like wrap it up and do a release and all that sort of stuff. This new library will be part of the JDK and will just come like when Java 24 lands or whatever it is. That bytecode library will already be up to date. Bytecode doesn't change all that much, all that often really, but the version numbers and stuff change anyways. So that will be, I'm actually kind of excited about that in a nerdy sort of way because it will make writing bytecode much simpler once you understand bytecode. So yes, yeah, it's called the class file API. Do you see what a JEP that it's targeted for? Okay. I think that's something, I could be wrong. I think that's something that Brian Getz has been kind of promoting. Yeah, that's what I thought. All right, so my better gizmo is in. Okay, so that's all I have. How I mentioned earlier, there was nothing about it. This is the entire Maven mojo. It literally all it does is it collects stuff from the POM and not even a lot of that. And then it just calls the generator, but the generator is pluggable based on some property. So if you go look at, for example, this configuration, all I do is I call Maven and I tell it which generator to use. And I don't know if any of this matters to any of you. I got clever with it because I used generator as an enum. And so I love to abuse enums because they're fun. In this case, because enums are named, right? I can just go grab the generator with whatever name that property was and use that as a factory to create the actual generator that I'm using. If you're interested, that's how I get from a Maven POM file off into a generator. But you can do the same in Gradle. You can do the same in Ant. It's just some sleight of hand. That is the last example I have. If you want to do your own research, these are where you can find these. Java Poet is great and Kotlin Poet is great. In my Critter project, I used to use Roaster and then Kotlin Poet, but it got weird because I had like two vastly different branches. Now I use Java Poet on the Java side and Kotlin Poet on the Kotlin side because they're pretty same. Gizmo, like I said, is a Quarkus project. This is where ASM is, and Byte Buddy is here. But yeah, that's that. Any questions?
Yeah. For example, if we have roster or Java code, we provide code like a string. How to debug this code?
How to do if you have your code as a string,
Yeah.
and how to decode it, debug it.
Debug, yeah.
Well, when it compiles as part of your build cycle, at that point it is literally. Let me show you what that looks like. Let's rerun roaster. When you're compiling it, no. Well, I mean, I'm gonna say no, because the compiler is kind of its own thing. But when you're running the generated code, the reason that I tend to prefer source code generation is if something goes wrong and you want to see it, you can actually come in, and this is the generated source code. So part of the generator stuff magic that I have going on is I tell Maven, I'm generating code off in this other directory, add it to one of your source roots. And so when you compile, it will actually find this .java file and compile it as a normal class. But then what that lets you do is you can come into this source file and just click on the border off over here and say, I want to set a breakpoint on here. And then when you run it, it'll stop at that breakpoint like it's your normal manually written source code. And that's why I tend to prefer source code generation if you can do it, because if something breaks, you can't really fix the code necessarily because it'll be regenerated next time you run your build, but you can figure out like, oh, I was assuming it wanted this, but it actually wants that. So you can at least try to see what it's doing with your input and why it's failing. With the bytecode stuff, good luck. You can decompile it. IDEA will let you decompile it if you just click on the class file, and you can kind of get a sense of it. But I don't think you can set breakpoints. Yeah. Yeah. Right. If you own the source code. But if you're calling out to generate a bytecode, you're like, I don't know what's going on. Like I said, you can decompile it, and IDEA is pretty good about it. You got to get a sense of what IDEA thinks the source code looked like back when it was still source. But you can't modify it, of course. Yeah.
Interesting. I guess with the example you've covered here, they're all imperative code generators, right?
Mm-hmm.
Either generating bytecode or generating source code. You ever use template-based code generators?
Yeah, the question is, these examples are all source code generators or bytecode generators, and have I ever used a template code generator? And yes, so you could use something like FreeMarker, Velocity. There's a few. Quarkus actually has its own template language called Qt, which Qute, which we use for like some more front end sorts of stuff. It's sort of like a nicer JSP, if you will. Yes. Oh, right. Oh, that's what I was trying. There's one called String Template, which is a very, I won't say basic. It's a low ceremony templating library. So you could do that. You could use a string template, and you could even do that in conjunction with Roaster. Yeah. Right. Yeah. So in Eclipse collections, they have like an int list or whatever it's called, and float list and char list. So they actually generate source code to build some of these other types rather than trying to hand code all of this. It's not cheating. It's leveraging the tools on hand. But yeah, you can use it. You can use a template to generate that. And again, you could use string template, dump it out to whatever generated source directory you want, and then just tell your build tool, hey, when you're compiling source code, also go get that stuff over there and compile it.
What I'm trying to understand the style of imperative generation where you can programmatically generating code, right? You can see that for bytecode. It's interesting with like the generating source code. I'm trying to sort out like where I would want to, let's say, use that
pre-marker, I've used velocity, I've used string template. Pre-marker and velocity I used to use for doing the name-based generation. Like I define something you were talking about before, like a UML, model, let's say, and then I can generate, let's say, all the supporting, data access stuff that I want to do, right?
Right.
So like there's something that's there. With the especially once again, using it for like it's the same thing, let's say, like you said, the stuff list on this, it's the same structure where it's like a different type that I need to generate.
Right. Where that line is between using a code, just to repeat the question, between using a source code generator versus a template.
Well, once again, I look at it as like you either have template-based or imperative. So imperative, like you basically got a program that's generating.
You could do both, honestly. And in fact, in my critter project, I kind of do what you're talking about. There are some methods that are just like, here's a method of the whole cloth, just go add this. And sometimes it's templated and sometimes it's not. So some of it, where that line is, can be a matter of preference. I've found if you go completely template based, it's sort of fine, but you have limited options in terms of, well, traditional coding, but also just in terms of like your variations of like what you, like how complicated can you get? How clever can you get when generating stuff? Because you're basically using a whole template all at once, without a whole lot of options for repetitive stuff. You can get around that, but you start building out some of the same infrastructure that some of these libraries. If you were to use Roaster, for example, you can actually do a bit of both, because you can actually say, here's a whole method, here's a class definition, and just here's your source code. But then use the API around it to kind of fine tune some of the stuff on the periphery of your type, for example.
How I describe this to in IntelliJ itself, you actually get templates built in. You can add
Yeah.
yourself, right? And I think it's actually like is it using yes, it's live templates.
Live templates, yeah. I don't think it's either, because the variables don't remind me of either, because like the variables are like percent something percent, and then I mean it might be, but I don't remember Velocity using the percent delimiters like that. But maybe it's configurable. I don't know. But yeah. Yes, sir.
I think it's somewhat similar because I was confused why I would use this versus just a string builder even.
Right.
And my question, do I even need Maven plugin? Because this seems like I can just generate it at runtime and execute it.
No, you don't. I only went the Maven route. The question is, do you need Maven, or you can just generate it? I only did the Maven thing simply so I could change the little drop down, change the property, and then run it. It was the simplest way to move from this to that, without a whole lot of ceremony.
That would be the answer. You don't need a build process. You don't need a build.
No, you could do it completely.
If you decide to like build the main user enters something on the web page.
And in fact, for the Gizmo stuff, we actually, it happens during the build process because that's when all our bytecode stuff happens. But we actually do generate the bytecode like on the fly, and I think we inject it into the running class loader. So you don't have to write bytecodes out to memory. You could just inject it into your class loader, and just have it completely done dynamically in memory and never touch the disk at all. A lot of agent stuff is done that way as well, manipulating your bytecode as it loads to insert telemetry data or whatever.
I've known about ASM for years. I've heard about
Yeah. Gizmo, yeah. I like Gizmo quite a bit. In the next version of Morphia, I'm trying to decide if I wanted to do source code or bytecode generation. Does it generate default methods?
I was just looking at like the types that are when you cut off the list. There was
When you're creating a method? Oh, this actually is, this is literally the Java lang reflect modifier. So if you've done anything with reflection, these are all the normal modifiers. I don't know that default is one of them, but maybe it is not actually. I haven't actually, now that I think about it, default abstract. I don't, but no, that's an interesting question. Like, how would you generate an interface with default methods? No, public abstract. Interesting. I don't know how you do that. Yeah. So, but yeah, I love it. Anything else?
Yeah, I have some questions here from the crowd.
Oh, from online. Yes, absolutely.
From online, a caller from Minnesota.
Up in Lake Wobegon.
Java code generation, but you can,
Okay.
take them as they come. What version of Linux is that you're using? It's like KDE Plasma, like on the Stream Deck.
It is KDE Plasma, and I'm running on Fedora 30, whatever the latest one is, 35, 32, 36, something in the 30s. I updated sometime this fall, but it's the latest Fedora, whatever that is.
Cool. And I don't know if people can hear me, but you might want to just briefly repeat the question. Is Marcus' team going to support Bazel?
Oh, is the Quarkus team going to support Bazel? Probably not. Our focus is on Maven and Gradle because those are the primary build tools. That said, we have a project called Quarkiverse, which is the Quarkus universe, where we have hundreds, including one of my own, of community contributed extensions. So if you really like Bazel, you can maybe try to wire that up. I don't know even what that would look like because there's a lot of work that goes into the Maven and the Gradle plugins.
Okay. And finally, do you know of any good libraries for JavaScript generation?
Oh, well, there's any generators for JavaScript. There's FreeMarker, there's Velocity, there's String Template. Yeah, I think that covers the book. I have no idea.
Okay.
I have no idea. JavaScript is such an amorphous language anyways. There's not a whole lot to like hang an API on, in a sense. Fascinating. I'd never thought about that question. I'm going to guess there's probably not. Because you can literally just, JavaScript will take almost anything you give it. And this is TypeScript. One more question.
Assume Quarkus team has a great experience parsing bytecode. So the question is, what is the fastest library for it? Right now, he or she uses JavaSys.
Wow, JavaSys. I didn't realize that was still a viable. I guess depending on what version of bytecode you're using. Like the question is like, what's the fastest bytecode parsing library? Parsing or generating?
Parsing bytecode.
Okay, parsing bytecode. There is one called JavaSys. I was under the impression that it was dormant, we'll call it. It may not be dead, but it's sleeping on its back. For older bytecode, that's probably fine. If you're using newer stuff, I'd be really surprised if it still works. In terms of speed, probably ASM is going to be the best. Is going to be the best one around, speed-wise. It's a whole other thing. Yep. It's pro. It's.
What are the difficult challenges you face when there is a Java version bump, apart from the version number changing, when you generate bytecode to generate code?
The challenge is the question is, what challenges have we faced when there's a version bump when generating bytecode? And in the Java version, yeah. On it, like I said, the bytecode doesn't change a whole lot. So you could actually, to solidify the point, Quarkus 1.0 was actually written to run on Java 8. And it's still essentially the same bytecode generation. And now I don't know if we made the official decision, and I might get in trouble for saying this, but we're talking Quarkus 3 now, and we might target Java 17. because it'll be a little bit before Quarkus 3 officially is here, although we have alphas coming out now. But the bytecode generation has remained largely the same because it's the framework itself, the bytecode itself is fairly stable. It's when you start getting newer things like Java 8 added invoke dynamic, so you have newer options to do things perhaps more efficiently or with fewer bytecode in the case of like invoke dynamic. But it doesn't necessarily break the old ways of doing things. So you can keep generating Java 5 bytecode and it'll just work.
The only problem I face with in ORM, specifically with the API.
Yeah. But that was a source break. That wasn't a binary. Yeah. But for the most part, once you've got your generator working, unless there's a reason to go back and update it, you can almost let it coast for as long as it keeps working.
Going back to Lombok, you mentioned at the beginning of the presentation. I know it's pretty popular with record construct.
The at data, yeah.
But there was a lot of buzz about record basically killing Lombok. Very bad.
Yeah. Yeah. So I have a library that I like to describe as Hibernate, but for MongoDB. So I do a lot of reflective sorts of operations to figure out like what an entity is and how I can marshal it in and out of the database. Hibernate has the same issue. Jackson has the same issue. What makes Lombok less than ideal? I'm trying to be political about it. It does things in ways you don't necessarily expect, and can make it hard to evaluate generically, not in Java generics, but just in a generic fashion, to parse the reflective data coming out of a class. For example, like the constructors, it will generate constructors for you, which is sort of nice, until you have a mapping library that specifically needs a no-arg constructor in order to hydrate it coming out of the database.
I've seen that come up with like deserialization. You don't have a no-arg constructor along.
Right.
I just remember that. I don't remember that. I remember that like breaking a whole bunch of things in serialization.
It breaks. I had a user request actually a couple years ago about, can you add support for this and that so that I can use Lombok? And I was like, I looked into it and it actually made my life more complicated to support like that one little niche use. And ultimately said no. And I wrote like a better way to do it. Like I wrote support to actually go out and discover like, oh, here's a full constructor, rather than trying to like string in Lombok's weird annotation constructor stuff.
I think our solution would be have to add no-arg constructors, but then you violate
Right, exactly. If you're going for immutability and you have a no-arg constructor that you then come in and backfill the values, yeah, exactly. Which is why I went for the constructor approach myself. Yeah. Cool. Any other questions? I'll put that back up for those who need it. No? Oh, one more. Yeah, or not necessarily one more, but another.
Yeah, so it might be a little broad, but do you have any thoughts on AI code generation?
Do I personally have any thoughts on AI code generation?
like the
GitHub Copilot. The Chat GPT that had just absolutely ruined my Twitter timeline the last couple of weeks. So there's a guy named Lucas Eater, I think his last name. He's the Juke guy. Love him. A lot of these library authors have gone and said, hey, AI bot, go write me code that does this. And literally what the AI bot is doing in a lot of cases is literally just regurgitating example code off of the websites. At the moment, it's probably useful for like reference stuff. sort of like when I had that plugin, it's like, what would the ASM code look like? Right now, those AI bots will get you in the ballpark to maybe like, I was like, oh, that's how that's done, but you have to actually refine it to make it actually work. So I think right now that's where they are. I was talking to one of my kids today, like there may be a time when AI replaces us as code generators, but I hope to be retired by that point. I don't think they're that great now, but AI is one of those things where once it hits that inflection point, it's just like, and suddenly, everything is new. So 3 years from now, AI might be just totally ravaging the workforce. I don't know. Right now, I personally wouldn't use it because it just doesn't seem.
There's also potential legal risks on using some of it.
Yeah.
Because it's trained, the legal issues, it's trained on real code, and you don't necessarily have the
And
copyright.
some of that code is GPL'd.
Yes.
And
So you can
even if the chatbot gives it to you, and you're like, I'm going to take this code this AI gave me, I'm going to put it in my project, and now look, it suddenly works. This new feature is amazing. But now you've got GPL contaminated code in your system, and you're liable at that point. Yeah, there needs to be an indemnity clause.
Yeah, it's risky to use you can use it privately, but I wouldn't use it as a company.
Yeah,
It's very risky.
it's a great learning tool for sure.
Yeah.
And it may be something really amazing in a few years, but we'll see.
And I will be so like 3 years from now. My friend, they have like architecture team. He just texted me. It says ChatGPT just passed all our architecture interviews.
Someone actually put one of those against like one of the FANG interview whatevers and scored like 80% or whatever on all their quiz. So it's getting there. Soon we'll all be out of a job. But we'll see. Anything else? Fantastic. Thank you.
You want to take over and your screen, share your screen, okay?
Yep. All right.
Are we doing the?
Are we doing
Yes. Yeah, we're doing that. Yep, absolutely. Get, yes. All right. Give me 1 second here. Thanks again, Justin. That was awesome. Just to learn that part of the programming language and the bytecode generation. I don't think a lot of people necessarily work with that, or at least mere mortals like myself. So,
like you said in my bio, I've been doing Java since '96.
Yeah.
So since there was a Java, I've been doing Java, and until I joined Orca's team 3 or 4 years ago, I'd never really done much with bytecode. But now it's a large portion of what I think about in general.
yeah, it's definitely educational. Yeah. So just to wrap up here, we got a couple of things that. Okay. Yep. Just some upcoming events. I know I'm sure I'm missing a whole bunch. I just need to figure out what's going out there. But we're still trying to plan a Garden State Java User Group Java Day. This is by Oracle. So we do have a tentative date for that, but that will most likely change based on some conversations I've had with Oracle over the past 2 or 3 weeks. There is a local conference that is in March, on March 17th and 18th of next year. It is the Trenton Computer Festival, which has been around since 1976. With that is the TCF IT Professional Conference, which first launched in 2006 and is always on the Friday before. So the first one, the TCF, is basically a conference for everybody. You don't have to be, a full stack developer to attend these. There might be at 1 hour sessions on how to use Windows 10, for example. So the skill level for people to attend runs the entire, runs the entire spectrum. The IT Professional Conference, that one is a little bit more, oriented towards Java developer or any developer for that matter. So look for information on that. I have a call for papers on the IT Professional Conference, since this is the second year I'll be the chair of that. And so if you're interested, please reach out. Upcoming meetings, we're getting into the final details for Mark Heckler's visit next month. This will be on January 17th, and that is the third Tuesday of the month, not the second. So Mark will be here in town to visit us and the New York group a day or so later. We're working with Rustam Memandarov to present with us in February, but you notice the date is Valentine's Day. And, I've been smart enough, to not hold a meeting on Valentine's Day. So look for, once we get everything squared away, I'll let everybody know.
And it'll be an online meeting.
We'll be here, but Rustam will be, right, yeah.
Okay.
Yeah. So,
It won't be the 14th, it'll be.
I don't know, it could be the day before, it could be, who knows? So to be determined. And then,
Very lovely.
yeah. So Basler Rahman, he's works for Contrast Security, is another InfoQ editor that joined earlier this year. He presented with us back in July. So he's interested in doing a presentation on the top 10 Java features. So he's been doing some InfoQ news items on the individual the JEPs. So you can find that on infoq.com. And then we're still trying to reach out to Cameron Purdy for the April meeting. So look forward to that. For details, we hope that he'll be able to come visit with us. And just learned that Mala Gupta from JetBrains might be available in April or September of next year. So this is something that was just, we just learned last night. So yes, yeah, absolutely. That would be, that would be.
Is that Cameron Purdy talked about ecstasy?
Yeah, he talked at the New York group last month.
Yeah, last month he did that at the New York Java Seg, and it was interesting.
Is it? Yeah.
So it'll be. I hope you can get them because it's a really interesting subject.
Yeah, if you're interested, if you go on infoq.com, Ben Evans, who's one of the Java editors, did like a long Q&A with Cameron earlier this year, I think, or late last year. You can find that if you do a search. So that's a good half-hour read for that Q&A. So, and our friends of GSJUG, New York is meeting tomorrow night, and Ken Kusin will be talking about functional Java, Groovy, and Kotlin. And then on Thursday, the Philly Jug. So this is the week for all the jugs to have their meetings, right? Reza Rahman, who is one of the Jakarta EE ambassadors. He started this, was the Java EE Guardians. Thank you. Yeah. So we are technically a member of the Jakarta EE ambassadors. That's another thing we do. So he'll be probably in Philly, since he's in the Philly area, talking about fundamentals of diversity and inclusion for technologists. And then the Atlanta Java group on the 20th, that's next Tuesday, we'll have the ever awesome Venkat Subramaniam to talk about exception handling in functional and reactive programming. And then our New England Jug, or I think they're now called Boston, they have Quarkus for Spring developers on January 12th. So they're not having a meeting this month. And I think that's it. All the others. Oh, I'm sorry. Oh, no, that's old. So ignore that. That happened last month. I don't think Chicago's doing anything this month. So I reached out to Mary Grogleski, but I didn't hear back. So anyway, so enough of that. We have our usual giveaway of an IntelliJ IDEA license. If you would like to, interested in the raffle, please scan that code and fill out the form. You'll be asked for your email address, and then you'll be asked, though, if you would like to be on the distribution list or not. So, but the email address is required, if you happen to win. So we'll leave that up for a few minutes to do that. And I guess for the folks who are visiting with us remotely, I don't know what the pizza situation is like, but it's all gone. Oh, beautiful. That's perfect.
I have a card for it.
so that's good. It's always tough to This is part of the reason why we ask if on Eventbrite, if you're going to attend in person or not. Too. This is so we can gauge how much we can purchase, for But I'm sure there'll be, if there's leftover, folks will take some home. So, but
I think we have a lot of students.
yeah, that's right. Yeah. So yeah. Anyway, I don't know if anybody needs more time to scan that, but fill out the form. So you'll hear from us on Meetup. My distribution list, Eventbrite, you name it, getting ready for next, and Twitter, right? And so as I always like to end, with my slide, it is that time to celebrate the end of a long day. And with that, if there's nothing else, where's the Zoom? Do I have to stop sharing? Right?
I don't know.
Okay.
Now I'm confused.
Okay. Oh, here.
There you
All right,
go.
there we go. All right. So, without further ado, wish everybody a good night and safe travels home to everybody who's here. And thanks again for coming out. And also have a great holiday.